Hello everyone. So today we are going to look into that what are the easterly trade winds and the westerlies. For this we need to know that what are the pressure gradient force and the Coriolis force, which plays a very important role in the direction of the easterlies and the westerlies. What is pressure gradient force? Pressure gradient force is the force which arises when there is some pressure difference. Like we can say that this is a position A and this is a position B. There is some pressure difference between these 2 points. So this region is of high pressure and this region is of low pressure. That's why we can see a pressure gradient force from high pressure region to low pressure region, and this plays a very important role in the direction of the winds, because the direction of the winds is from high pressure region to the low pressure region. Another force which plays very important role is Coriolis force. It is the force which is created due to the rotation of the earth, and due to this rotation of the earth it plays important role in the movement of the wind. Due to this force only, the direction of the winds in the northern hemisphere would get deflected to the right, and the direction of the winds in the southern hemisphere would deflect to the left. This Coriolis force only deflects the winds to left and right directions. Now there is another force, that is friction, which works in changing or resisting to the wind movement, because these winds are on the surface of the earth. That's why, due to some irregularities on the earth's surface, the friction offer the resistance to the wind movement. Majorly these three forces, pressure gradient force, Coriolis force and friction, plays a role in deciding the direction of the winds. Moving on, now we are going to look into that what is the pressure belts and the planetary winds. First of all, as we already know that equator is a region of low pressure, and this subtropical high pressure belt, we are aware of this. This region is of high pressure. Now let's say this region is of high pressure and this region is of low pressure. What will happen then? Normally, pressure gradient force will exist, because pressure gradient force will exist wherever we can find some pressure difference. As we can see here that the subtropical high pressure belt is here and equatorial low pressure belt is here. Pressure difference is existing here. That's why the direction of the pressure gradient force will be like this, from high pressure to low pressure region. But as we know that force will also exist here. Due to the Coriolis force, we can see that there will be a deflection towards the right in the northern hemisphere. So if we will look in the direction of the wind, in the direction of the wind, this is the right side. So wind will get deflected to its right. We need to look the direction of the wind, actually in which direction it is flowing, and then we have to deviate that wind to its right. So direction of the wind will be this. Now this deviated to its right in the northern hemisphere. This is how the winds will be present in the region of subtropical and equatorial belt region. These winds are known as trade winds. Now the next one is this subpolar low pressure belt. So if this is a region of low pressure, and we know that subtropical high pressure belt, direction of the wind should be from high pressure to low pressure region. Naturally this direction would be there due to the pressure difference. Direction of the wind from high pressure to low pressure. That's it. Now the Coriolis force, and according to the Coriolis force, the wind would get deflected towards its right. So right of this wind. We need to look from the direction of the wind and then we have to deflect it to its right, and deflect it to its right. So that's how all the winds in this region deflected to its right. Now in this region, as the polar region is of high pressure and this region is of low pressure. So wind will move from high pressure to low pressure. Pressure gradient force? Yeah. So pressure gradient force is from high pressure to the low pressure region. Now the Coriolis force will be to the right of this wind, to the right of wind. We have to consider the direction of wind. Then wind is this direction, then to the right of this. Deflection to the right of this. Now we need to look at the naming convention of these. So first of all, if we are going to look at these winds, these trade winds, these are easterlies. Name of the winds is based on their direction of origin. So they are originating from the east and moving towards the west. So because they are originating from the east, that's why these are known as easterlies. Polar easterlies because originating from the east. These are westerlies because these are originating from the west. So naming convention is based on the origin of the winds. Now moving on and deciding the direction of the wind in the southern hemisphere. So this region is of high pressure, subtropical high pressure belt, equator is low pressure belt. Direction of the wind is from high pressure to low pressure, but as we know that the Coriolis force in the southern hemisphere would deflect the wind to its left. To its left in the southern hemisphere. To its left, all the winds to their left. These are the easterlies because these are originating from the east. Now here subpolar low pressure belt. Here low pressure would be there. Direction of the wind from high pressure to low pressure. Pressure gradient force is from high pressure to low pressure region. Now these wind would get deflected to their left due to the Coriolis force. So would get deflected to its left due to the Coriolis force. Direction of the wind will be this, westerlies. Now the polar region is of high pressure belt. As it is high pressure belt, direction of the wind would be this. So the pressure gradient direction is from this high pressure to low pressure. Wind would get deflected to their left due to the Coriolis force. So direction of the wind is this. So this is how the easterlies would be present here. So all these pressure belts and the planetary winds have their directions based on the pressure gradient force and the Coriolis force. This is how the direction of the winds would be there. These are the planetary winds. I hope you understand the topic well. Thank you for watching.